essentially this session should be, I want to treat it as a introduction to C++ coding of CompuCell modules. And normally we would do hands-on session where everybody would join and complete the tasks that I'm doing on my laptop. But somebody has issues with sound. Hold on. Let's see.
You're fine, Maciek.
Yeah, okay. All right, so the goal for this session is for me to go over some introductory material, show you how to get started, and then I will just show you a simple demo, how I code up C++ module. And what I'm going to show you is actually the tools that we are using internally when we are developing plugins. So it's the techniques I'm going to show you is something that we use in our daily, I would say weekly routines when we code CompuCell modules. But you can use the same techniques to write C++ steppables in the cases where you discover that your Python code slows down your simulation significantly. And that can happen. That can happen for various reasons. On average, you'd expect Python code to be 100 times slower than that equivalent C++ code. Of course, that doesn't apply to situations where you're using NumPy. For example, if you're doing linear algebra using NumPy, or you're doing equivalent linear algebra using your favorite C++ library, the speed should be comparable. And the reason for that is that NumPy is essentially calling C or C++ code underneath. But if you're writing just plain vanilla Python code, on average, I'm just saying on average, this can vary, and you can use different optimizations in Python. But I would say you'd expect to be 100 times slower. So let me actually get going with this. So what do you need to get started with C++ development of CompuCell modules? So first thing, you want to install CompuCell3D using the installer that's correct, that's appropriate for your platform, right? And all of you have done this. So by now, if you're using version 4.4.1 of CompuCell, you can check off this item. The next thing is to clone or download CompuCell3D source code. So this is the link that you would follow, and this is the screenshot of the web page. And by the way, we will I will go over those steps and I will show you live how this is done. So normally you can if you don't use Git, you can click the download zip and you would unzip the source code, and then you'll be ready to go. Alternatively, you can use a Git command to clone the entire repository. So whatever you do, it's it's up to you. There's I personally prefer to use Git, but if you want to just experiment with CompuCell code, or you want to just see whether coding C++ CompuCell3D modules is for you, just go ahead and download zip. There's no harm in doing this. So the next thing you have to take care of is make sure you have right tools for C++ development. What are the right tools? So first of all, you don't have to install, if you're on OS X or Linux, you don't have to install compilers, because CompuCell3D comes with the compilers, with C and C++ compilers bundled with the installation package. But if you are on OS X, you still need to install, the developer tools. Those are, like linkers and other developer tools that are needed to essentially, build the tools, the C++ code on your Mac. And all you have to do really is just run this command, xcode select -- install. Okay, so you do it once. Okay. It might take, depending on internet speed, it might take a few minutes, because I think this package is not that small, but you do it once and you're done. The second thing you need to do, if you are on Mac, you need to make sure that you have your development kits, software development kits installed into your /opt. /opt is sort of like standard location for those SDKs on OS X. It's not technically standard, those SDKs sit in different directories, but since we are building Conda packages, the Conda community decided that the /opt is the place to put additional software development kits for OS X into this folder. So if you are on Mac that has Intel processor, you would need Mac OS 10.10 SDK. If you are on ARM processor, which is M1, M2, M3, whatever, the new Apple processors, you will need 11.3 version of SDK. And you can get those SDKs by visiting this link. And it's a standard link that's being given, by everybody who is building packages for Mac. So I got my SDKs from there. So after you get those SDKs from those websites, from this website, or this is another link that's actually more direct, and you can get both SDKs following this second link, your OPT directory should look like that. And you have to, of course, you might have to change your permissions, you might have to be root to install those SDKs, but those are things that if you are really serious about C++ development on Mac, you can contact us and we can help you out getting started. If you're on Windows, you have to install Visual Studio 2015 Community Edition. This is free edition, and you have to make sure that you install this exact version, not 2017, not 2019, not 2013, just this exact version. And if you do this, things will work out of the box. Sometimes, if you search internet for Visual Studio 2015 Community Edition, you might get plenty of links. None of them are too helpful. So it took me a little while to actually find the recent links. And this website, Stack Overflow, this is the direct link to the issue. It actually has the curated links for the point to download of Visual Studio 2015. And if you click on those links, they should point to Microsoft websites. So just double check that you're not getting to some other website. But last I installed my Visual Studio through those links and it worked fine. If you're on Linux, the only thing you have to do really is just install CompuCell3D and you're all set. So Linux is probably the easiest place to get started with your with C++ development of CompuCell modules. Okay, so how do we build CompuCell3D C++ modules? The best thing to do is to essentially read developer's manual that we wrote a while ago. It says, the version is 4.3.0, but nothing has changed since then in terms of like API. Our API has been stable for quite a while, meaning, the API of C++ code of CompuCell3D. So, even though this says 4.3.0, this has fairly up-to-date information. You click on this, you will get redirected to actual manual. This is online manual. You can download PDF, and there are many sections of this manual that really walk you through very basics. Walking you through how you set up your computer, making sure that everything is ready to go. Some of the information, I must say, some of the information might not be most up to date in terms of getting started with preparing your computer to compile the CompuCell3D modules. But when it comes to, for example, actual code of C++, modules that you will develop for CompuCell, I think this manual is up to date. So it's a good idea to have this as a reference. And the goal for this session is for me to essentially just pick one or two examples from this manual. Actually, no, I'm not going to pick one of the examples from this manual. I will write it from scratch. I will show you how to write a module that I thought is appropriate as an introduction to coding of C++, modules for CC3D. One thing to remember, and this is, I've learned it not the hard way. I mean, it didn't take me long to figure it out, but if you're on Mac OS and if you, let's say you did all the steps, you're ready to compile your newly written C++ modules, you type make, and you might get this warning, unsupported TAPI file type. If you get this warning, typically the only thing you have to do is just have to deactivate conda environment if you're in the conda environment. Once you do this, you type make again and things work out. So I actually spent a few minutes yesterday battling this warning and figuring out where it comes from. Okay, so so let's get started. I'm gonna stop my presentation, and as I mentioned earlier, the content of this presentation is pretty much based on the material covered in the developer's manual. So once again, go read it. If you find some inconsistencies with what I'm showing today and the content of the manual, let us know. If something is wrong, let us know, we'll fix it. But other than that, we are ready to go in terms of CompuCell3D. So let me bring my terminal here. So first things first, this is my CompuCell installation. I just installed it today. This is, I did it at 8 a.m. Just trying, yeah. Let me see if it works. Okay, so cd. So this is first time I'm running it today. So I ran it yesterday, but I installed it fresh so that we can start fresh. On Mac, some of you may have noticed that the initial run, when you issue a CompuCell3D command, the initial boot up of the software takes a while. On Windows and on Linux, it's much faster. But then when you run CompuCell again, it's much faster. The boot up time is much faster than the initial startup of the software. All right, so we should be ready to go. This is my CompuCell3D. I can, I don't know, let's see if it works. So this is freshly installed. Let's see, your favorite CompuCell cell sort simulation. Okay, that looks good. All right, we are ready to go. So first things first, I said install CompuCell3D. The second thing I've said, let's bring up the presentation, is let's get the source code. That's what we're going to do now. So, and by the way, the manuals are, if you go to CompuCell3D, you click manuals, and this is your developer's manual. So you click it, and it's there. Okay, now let's install the source code. Let's download the source code. CompuCell3D. Now that's GitHub, actually. GitHub. Okay, first link, that's good. I'm going to click it here because that's the repository. And I'm going to pretend I don't have Git. I have Git, but I'm going to pretend I don't have it. So I'm going to download the zip. I'm going to download the zip. Remaster. Okay. And let me open up. So I'm going to, where am I going to put this? All right, let me put this in at the top level. CompuCell master. I'm going to unzip it, and I'm going to copy it to top level directory. That's not very fast, is it? I'm going to be waiting too much time. But actually, I don't like this. There's a better way to do it. Let's do unzip. Oops. Let's see if this is faster. I should get this guy. I'll write this file. Yes. So this is my source code. Okay. So this is the latest snapshot. And what we are after here, what we'll be using soon is the developer zone directory. So going from the top, this is my location of my Git repository that I downloaded or cloned. I'm going to go to CompuCell3D folder, and there is your developer zone. This developer zone is where all the custom code that you will write will reside. So what do we do next? Next, we have to open, I'm going to open another terminal here. And I'm going to give it a different color so that we can quickly identify it. And we'll open 10.H.E. This would be TW. So here is my 10.H.E window. Okay. Now, there is this CC3D C++ menu here. All right. And it has two menu items that are of interest. One is generate the new module. So clearly, we will use this generate new module for sure. But before we can generate new module and compile it, we have to prepare the developer zone, essentially pre-wire developer zone for compilation. So in other words, let me go back here and explain what I mean by that. All our code in CompuCell3D, the way we are managing the compilation, we are using CMake. So here you have CMake file that describes how to compile the modules in developer zone. Okay, it tells you which libraries to use. It tells you which subdirectory to include, and so on. But by itself, this is not sufficient to compile anything. Before you can compile anything using CompuCell, you have to run CMake, or you have to run configurator script that comes from that CMake provides, that parses the CMake file and generates files that are actually directly responsible for compiling our code. So this step can be done manually, or we can do it from 10.H.E. Okay, so I'm going to go to CC3D++, CC3D C++ menu. I'm going to click developer zone. Okay, and the dialog pops up. And this dialog is fairly self-explanatory. So, to configure developer zone for compilation, please select CC3D Git repository and build directories and click configure. So we're going to select our repository. So I'm going to click this guy, and I know that my repository is here, right? I call it C++ CompuCell3D-master. That's what I'm going to select. You're selecting the repository. Okay. Notice that by default, the build directory has been pre-populated for you. So this is where the source code resides. This is where all the files that are generated by compiler and CMake will reside. Okay. And those are separate directory. And then we're done. All we have to do is just click configure. And let's hope that it works. So it takes a while. I mean, it doesn't take a while. It takes, just a little bit of time. Depending on the platform, it might take longer or shorter. If you are on, I think Windows might take the longest. But it looks like things went fine. If there were any warnings, you would see warnings at the beginning, but we don't see any warnings. We just see steps to compile. And this really walks you through what you have to do next. It says, now open the terminal and do the following. If you are on OS X, deactivate conda-based environment. This is the tip that I talked about earlier. To be honest, I wish I have read this remark earlier because I actually forgot that it's here. I had to Google it again. So conda deactivate base, I'm gonna type this. And what else? And then I'm gonna cd to this folder where all the files generated, all the compiler files are residing. And I'm gonna issue make and make install. Below, you see the output of the CMake configuration step. So CMake, as I said, CMake parses this, CMake configurator script parses this CMake txt that I showed you before, parses this, where is it? Parses this guy and generates a bunch of, directories. Let's actually take a look at them, how it looks, so that, you have an idea. So this directory has been populated by CMake, right? And you can see there is a make file. For those of you who have ever compiled anything on Linux or Unix or Mac, make files are the basic currency that developers use. This is how you tell how to compile big chunk of code. So this file has been generated by, it says CMake generated file, do not edit. And there are a bunch of, steppables. You can see there is a plugin. This plugin and, all those directories, they are placeholders. They do not contain source code. They contain instructions, how to build those plugins using the source code that resides in this directory, in particular in this directory. All right. So there we are. And I'm going to complete this step, and then I'm going to take some questions from you, if you have any. Okay, so let's go back to edit. So it says, okay, so let's do what it says. I'm going to open new terminal. Let's make it green. So green is the compilation terminal. So cd compusal, I think master is like this. Yes. Okay, so I completed this step. cd. Now I have to deactivate conda base. Conda. You know what? Actually, I'm not going to deactivate it. I'm going to type make so that you can see the error. So it starts building. Yeah, so this is the error that you get during linking. Okay. We were talking about this. And by the way, my computer is M1. So, so I'm using, as you can see, I'm using 11.3 SDK. If you were on Intel Mac, this would be 10.10. And the CMake, our CMake automatically detects processor type of your Mac computer. So let me actually do conda. So notice here, I have conda base. This base in parentheses means that I'm within conda environment and the environment is called base. If I type conda deactivate, I'm no longer in conda environment. So I'm going to type make. So this should go fine. So this will compile all the modules that come with developer zone. So we have prepared, several demo modules. They are compiled, but they are not installed in. So right now I cannot use them. Okay. Maybe it's actually worth taking a little bit of time and looking over those modules. So let me let me bring my PyCharm here. And, you know, we can look at growth steppable, for example. So in developer zone, I have module, a steppable, that's written in C++, and it's called growth steppable, right? So I'm going to open the C++ file so that you can see what it does. And as I said, those are the demo modules that are bundled with CC3D code. So our repository already contains those modules, okay? So if we look at what it does, you're familiar with start functions of steppables because you wrote Python steppables by now, I'm sure. And if you look at this code, it looks very much similar to your for cell in cell inventory in Python, and then you're doing a bunch of operations on cells, right? So it's very similar, right? It's not as simple as Python. So this is one caveat about C++. It's on average, if you code in C++, you should expect that your development speed, the speed with which you develop code, will be 10 times slower than the speed with which you develop code in Python. Okay, so this is just like, you know, based on my experience, and you will see that because I'm going to write code from scratch for you here. So here in start functions, we're assigning target volume and lambda volume to, you know, 25 and 2.0 values, and in the step function, we're going to be iterating over the inventory of cells, and we'll be increasing target volume by some value. I'm not going to explain this code here for now. You know, I'm just showing you what the codes that are bundled with our developer zone folder look like. That's what I wanted to say right now. So right now, maybe let me actually run the code for you that uses this growth steppable. So I'm going to open our cell sort simulation, and I'm just trying to find where the cell sort simulation is. The models. Okay, I'm going to open the simulation and I'm going to paste it here. Cell sort, growth steppable. All right. So this is my regular cell sort. If I run it, so let me actually show you what's going to happen. So let me run, I think, where is my CompuSol3D? I think CompuSol3D is here. Let's give it an orange color. Okay. For those of you who are on Macs, I strongly suggest you use iTerm tool because it has this nice feature where you can color your tabs so that, you know, by looking visually at colors, you can, you know, identify, you know, where different, the content of different tabs. So, all right, so let me open up this newly created, then I have I think it's in, isn't demos local? I think it's in demos local. It's in modules, models. Yeah, so this is the one that I just created. And I am going to run it. All right. So let's see what's going to happen. Nothing's happening besides it's cell sorting. It's just sorting, okay? So that's what it's supposed to do because I haven't changed any code. So it's just regular plain cell sorting that you get from with every CompuSol distribution. Now, I would like to use this growth steppable that I showed you here, right? So we have this growth steppable. And the question is, how do I know how to call it? I know that file is called grow steppable. It's reasonable to expect that the name of the steppable is also grow steppable, but where would I find the name, the actual name? Well, it is in proxy CPP file. So each steppable, each plugin has proxy CPP file where you specify how you can call a given plugin or steppable from XML. And this is the name I'm looking for. And it is indeed grow steppable. And when you write your code, you can call your steppable anything you want. It doesn't have to be called grow steppable. As a matter of fact, you can have multiple names for a same module. But I'm going to use this. So let me actually paste it in. Where's my code for CompuCell? Fusion Python. Let me close a bunch of those. Models. Should be models, right? Yes, grow steppable. I'm going to go ahead, open up XML, and I'm going to create this steppable, grow steppable. So what I did really here is I created, I'm going to call the grow steppable here. Now, I'm not sure if this will work because it might need some additional parameters, but let's see. And if it needs additional parameters, we'll find what they are by looking at. It's clearly not working. Okay, this is very interesting. So look, so I thought, we compiled this grow steppable, but it says exception during initialization, plugin not registered, grow steppable, right? Why it's not registered? Well, it's not registered because here we compiled everything. So all the code has been written to this, where is it? To this directory, but we want this code to actually go into the place where CompuCell is installed. So we have to type make install. In case you're wondering where it comes from, this is make, and you do make, and then you type make install. All right, so I'm going to type make install, and I'm going to try running again. CompuCell 3D, I think it's here. Let's see if it does anything. It doesn't do anything, okay? Because this grow steppable likely needs more setup. So how do I find what type of arguments I need to pass to this grow steppable? And I'm going to close it because we need to provide some arguments here. So we need to fill some XML. Well, there are two ways in this particular case. One way is to actually look at example that's already there in your developer zone demos. There are demos in the developer zone. So I can cheat and essentially copy this. That's what I'm going to do. And I'm going to run it again. And now we should see that the cells should start growing. They're not growing. This is really silly. Maybe they are, but they're slowly growing. Let me actually try running this. We should run, maybe we should run demos local. Developers demos. grow steppable. Let's see if this will run. I'm wondering why it didn't run there. This is really interesting. So clearly this simulation ran fine. If we could see that cells are growing, I don't know why I didn't. CC3D type grow steppable cell type. That's very good. So the reason why it's not running properly is because cell type is listed here as 1, but we have 2 cell types, condensing and non-condensing. So let's change this. So this is teaching moment, how to deal with things in CompuCell when things don't go your way. So I'm gonna rerun again the same simulation, but so I'm going to actually choose the simulation grow steppable. Yep. And what? Why is this doing so? That is not funny. ID. No, maybe it was right then. This is really interesting. Cell type. Actually, it should be type ID. Type ID, not type name. So my bad. This is what happens when you try to improvise, and that's fine. So 1 and 2. Let me actually copy this the way it is. Trying to see if there is anything that's. I see. That would make sense. The reason why it was not working is because I defined my volume like in such a way that all cells had fixed target volume and lambda volume. If I get rid of this, so I can actually comment it out, that was the reason. And I hope this works now. Yep. So this is essentially the basic crash course in how to get started. We haven't done actually any coding yet. We'll do it in a second. But how to get started with compilation. It took us a while, but well, it's 45 minutes, with presentation. So it's not so bad. Essentially, I would expect that if you actually work on your machine, Windows, Linux, Mac, whatever, within, let's say, 2 hours, you should be able to compile the developer zone that we are bundling with CompuCell 3D. Once you do that, the rest is much smoother. I mean, I don't want to say much smoother, but once you jump over this part, you should be able to write your own modules. So I'm going to take some questions if there are any questions.
I have a question.
Yeah.
How do we access syntax for example, looping over cell pixels, looping over neighbors, looping over, I don't know, setting field value, a certain value at certain location?
Yeah.
How do we find these types of syntax?
We will go over this. Just trying to see. It's actually, so those questions, so funny because this C++ menu is fairly limited, but actually it covers those questions that you asked. Clearly, if there is more interest from people who are, interested in developing C++ modules for CC3D. And again, the main motivation is speed. You can really drastically speed up the simulations if if your Python code takes forever. And at the end of, let me actually show you. Maybe you've seen it already. When you run your code and you hit stop button, at the end, you get this performance report. And the important thing is to look at how much time you're spending in C++. If the time you're spending in C++ is, I don't know, 5%, then it tells you that 95% of your time is being spent in outside C++. What does it mean? It's likely Python code. What Python code? Well, player, number one, maybe you don't have to refresh your screen that frequently. Maybe once every 1,000 Monte Carlo steps is enough, especially if you're running production simulations. And B, steppables. So if you're spending 95% of time in steppables, you have potential for, I don't know, 10, 15 times faster simulations if you rewrite this code in C++. So having said that, let me actually show you how to write your new module. Okay. So how do we get started? Well, you've seen already that, where are we? Let's go here. You've seen already that our gross steppables has 1, 2, 3, 4, 5 files. And one thing you can do, you can copy those files, you can create new directory, copy those files, rename everything, make sure that you also include the gross steppable in the main CMake. And then, if you're adding Python attributes, make sure you modify, Swig file and so on. Or you can use 10.H.E, which will do it for free, and it will do it much faster than you can, or I can. We used to develop C++ modules by following this manual process, but it was very tedious. It's very error prone. Dealing with this boilerplate code and adapting it to a new module was a major pain. And long story short, we wrote this little dialog that says generate new C++ module. Okay. So first of all, here we have to navigate to the developer zone directory of your repository. So I'm gonna do that. So it's master CompuCell3D, and there should be developer zone. I'm gonna click it here. Right. Now we have to come up with a name for our module. What I would like to do is I would like to write a module that computes the diffusion coefficients of cells. Okay, so I'm going to call it cell diffusion. All right, that's the name of our steppable. Code layout. The question is, do you want this code to be part of main CompuCell distribution, meaning, if I was adding new CompuCell modules, since I'm a CompuCell developer, I would use this option. But if you're doing it on your own and you're writing your own private module for now, I would suggest using developer zone, because that's where you want to be. So developer zone. The next question comes from where? What type of module is it? There are two types of modules: plugins, energy terms, or what is it called? Lattice monitors, or steppables. In this case, we'll be writing a steppable. Why steppable? Because it's, we want to show how much faster C++ steppable can be compared to Python. Okay. Then the question is, do you want to attach any cell attributes? Okay. Cell attributes means, do you want to attach any C++ object to each cell when the cell gets created? If you have such need, you can go ahead and do it. And, we can choose it. Why not? And do you want this code to be accessible from Python? Again, doesn't hurt for it to be accessible from Python. I mean, in this particular case, I don't think we will use this functionality. But remember, each plugin that you develop, each module that you develop, you can call from Python as well. So, okay, so that's all you have to do. So again, let me go back and repeat the steps. So it's gonna be developer zone, steppable, and we're ready to go. It will ask, are you sure you want to create steppable in blah, blah, blah developer zone? Yes. As a result, we can count how many, so there were new files created. So this is the object that will be attached to each cell. We're not going to use it, okay? But keep in mind that each cell can have additional attributes in C++, and those attributes will be only added where you include your module in the XML. There are, what is this? This is actually main cell diffusion CPP module. So this is where we will write our code. It has placeholders for us to use. There is a header file, in C++. If you have classes, you typically declare class in the header file, and you declare implementation in the C++ file, or CPP file, or CXX file. And there are a bunch of, auxiliary codes that, this is not terribly exciting code, forget it. If you are on Linux, it doesn't matter, or on OS X, it's only important for Windows. Has to do with dynamic libraries. Then there is this, cell diffusion proxy file. This is, we can specify how do we want to call our module in XML. We're going to leave it as a default, cell diffusion. We have to modify, we have to write CMake file. We have to modify other files. So this is the swig file. And this is the CMake file that we had originally, but it has additional line here, cell diffusion. So essentially, we are adding cell diffusion module to our main CMake file. This is the file that I showed you before, and we were discussing how CompuCell developer zone is being constructed. And right, so you see, this is the file. Previously, it didn't have this. It was just added right now. So now, we have this code, let's compile it. I mean, this code won't do anything. Actually, it will do something. And I'll show you what it will do. This code will go through in every cell in our simulation. It will print current step, and it will print cell ID and its volume. So it's ready to go. Let's compile it, really. So as you can see, we didn't write any code yet. We just generated code. All right, I'm going to do make. And notice that because we have changed CMake file, all other modules in developer zone will have to be recompiled. So that's the limitation. But we're done with this. I'm going to do make install. All right. Notice we have new directory here, a new library, cell diffusion. So let's see if this cell diffusion works. So I'm literally going to go to our old simulation that we had before. This one. I'm going to get rid of this steppable. No, maybe I'm going to enable back the volume constraint that we had originally. And now I am going to put cell diffusion. And what I should expect when I run this simulation, like this, and I'm going to call it cell diffusion. Just for fun, we can call it cell diffusion, XYZ later on. So that should be ready to go. Let me run CompuCell. So notice, this is new module that we have written for CompuCell. It's C++ module, and I want to see if I can Wait, what is this? So my cell sort simulation graph steppable should be loaded. And I'm gonna do, notice the output here. It's exactly as we expect, right? Current step followed by, every single cell in the simulation. So the steppable is working. All right. Let's do something, as I said, interesting. Let's, I said we were here. Where is the proxy file? Let's call it XYZ, just to show you that you can change it to anything. Each time you change C++ code, you have to recompile. So that's the downside of C++ in general. The downside is that you cannot really, I'm going to close the CompuCell. So there are two things you have to do. You change C++ code, you have to recompile and install. So make install. If you type make install, it will by default first compile everything and then install everything in the right place. And B, you have to close CompuCell and reopen it so that new libraries can be reloaded. If you don't do this, you will most likely be running with old libraries. If you're on Windows and you don't close CompuCell prior to issuing make install, you will get a warning, because on Windows, you cannot override the library that's being currently in use. That's the thing. So if I run this code again, I'm expecting that it shouldn't run, because I changed the name of the steppable, and that's exactly what happens. But if I change it to XYZ, where is my type XYZ, right? Because I changed it there. I'm expecting that it should run. And it runs, okay? So this is just a quick, quick way of convincing you that I'm not cheating and I'm actually doing live demo, and I'm using C++ code to include, essentially code up my logic of steppable. So this logic was pretty simple, nothing fancy there. Let us write something more interesting. So I am going to open CLion here. Let me open one. I like to open. And I'm going to bring the window in a second. It's on my another screen, so bear with me. I'd like to bring, I use tool that's more friendly for developing C++ code. And I think I'm there. Oh my gosh, this is worse than I thought. Okay, I'm gonna skip this. So this is my code that I have so far. All right. So this is the same code, by the way, that was generated by 10.H.E, but I'm using different editor because I kind of like this one more. All right, so we would like to do the following. We have 200 cells roughly. We want to record the position of each cell at the beginning of the simulation, and then at each Monte Carlo step, we would like to compute the displacement, the mean square displacement of each cell. No, the mean square displacement of all the cells in the simulation. It's a function of time. And then, from the slope of the dependence of, mean square displacement, we can, reason about the diffusion coefficients of cells. So I'm not gonna actually do exact, calculations. I'm just going to show you the technique, how to do it. So first things first, I need to, inside my class, my steppable class, so this is the steppable class, I need to define dictionary. So in C++, the way you define dictionary, there are many ways, but I like to use an unordered map. There are ordered maps and unordered maps. Maps, regular maps, are the dictionaries that have been in C++ since forever. The downside is that if you have plenty of elements, they are kind of slow, and they are like significantly slow. Unordered maps, they are hash maps. So they are as fast as Python dictionaries, and those are the ones that I like to use. And inside this map, I'll store tuple. Tuple is a list. It's like a list. It has 3 elements. It has like as many elements as you need, but it's like Python tuple. So my dictionary will look like this. So std map, it's a template. So
I think there's a typo there, unordered.
Ooh, yeah, thank you. So the key to this dictionary will be cell ID. Cell ID in CompuCell3D is a long integer, I believe. So I'm going to type long, and the value is std tuple. So now, and now you can fully appreciate how std tuple and sorry, of course this is wrong because it should go like this, and I'm gonna store X, Y, and Z positions of center of mass of each cell. So center of mass is double. Now at this point, you are entitled to ask a question: why the hell are we writing C++ code? Because why are we bothering with the code that looks so ugly? I mean, it's ugly code. Man, it's nothing intuitive about it. It's but the upside is that the code will run much faster. So the downside of C++ development is, of course, as I said, development time and its clumsiness of the syntax and all these other things. But the upside is that this code will run much faster. So the reason I'm defining it here is because this has to be persistent storage. So in other words, I'm going to initialize the content of this thing in the, I think, start function. Is it start function? Let's try it in the start function first, and then we'll see what happens later. And it has to persist throughout every call to the step function. All right, so this is it. Now, here in the start function, I am going to literally copy this fragment that iterates over all the cells in the inventory. I'm going to copy it here. All right, and that's what I'm going to do. I'm going to take name of my inventory. So this is my unordered map, and I'm going. So to get the cell object from the, so this is the iterator. Okay. Oh, you know what? I have to actually copy this guy too. And I have to copy this guy too. There's a bunch of declarations you have to do in C++. So here I'm declaring the iterator to the inventory. And to get cell object from the iterator, I have to use this special function getCell. It's It's not terribly pretty, but that's how it's done in C++. We, of course, could have simplified this syntax in CompuCell, but we left it for quite a while, and maybe since it works, we're not changing it. So ID. So I'm creating an element of the map. The key is cell ID, and then I have to use the make tuple function, where I'm going to store cell XCOM YCOM DCOM. All right. So what I did here in the start function, I'm storing essentially initial positions of cells, and I'm storing it in a dictionary that's labeled, that as a key uses cell ID. So what we can, yeah. So that should be fine. So if we want to print out what we stored here, how do we do this? I think we can use, what, for now, let's make sure that this compiles. I'm gonna comment out this code for now, and let's make sure that this compiles first. This compilation step. Okay.
Shouldn't it be double column?
Yes, exactly. That's what I found here, double column. Yes. Let's see. Great, so it compiles. All right. Since it compiles, we should be able to run it actually. But before running it, I would like to add a little bit of code. Let's actually put some code here. I'm going to copy this code in the step function, and I would like to print out, make sure that what we have stored here in this dictionary persists to the step function. And I'm going to show you how to retrieve the elements of the tuple in C++. So I'm going to declare that I want to essentially get this tuple here. So std tuple, and this will be double. This will be init COM, initial center of mass, equals this guy, right? So essentially, I'm extracting values pointed by cell ID from this dictionary, and I'm storing it in the variable initial COM that's of type tuple that has 3 components. And I would like to see error, write it to the screen, and say ID equals ID, like this, and then XCOM equals, and now it's interesting how you do this. So this will be std get 0, get 0 and So this expression, this function gets 0th element of the tuple init com. And I can continue with other components, but just for fun, I just want to make sure that this works. Now, you know, you can look up your C++ books. By the way, we're using C++ 11 here, or so. So the syntax, you know, is you know, if you haven't used C++ 11, you know, you might have not encountered those, but it's a good idea to actually switch to C++ 11 because it actually makes your life easier. Although it's kind of hard to believe that it makes your life easier when you have to write that much code to get first element of the tuple. And to be perfectly clear, you know, there are probably better ways to deal with tuples than doing this. I'm just, you know, I just picked the first example that came up and I started using it. So we wrote a bunch of new code. We have to do make install. And we are seeing a bunch of stuff, undeclared variable, this and cell. Why is it so? Well, because we have to declare those variables. So we have to literally copy those declarations from here. This is the problem with C++. It's not a problem, it's a feature. Before you can use any variable, you have to declare its type. So let's do it again, make install. All right. So now we can use it in our C++ code. And where is C++ code? All right. I think it's here. And we should see a bunch of printouts every Monte Carlo step. Yeah, that's fine. So looks like we're in business. I'm gonna close it. So now let's do actually what we want to do. So here, let's declare mean square displacement. And I'm just trying to see what else do we want to do. Sum of squares. Some squares. Squares. All right, so let's write the sum of square displacements. Oh, and we want to count number of cells. So long num. All right. So first things first, plus num. So with each iteration of the over inventory, we're increasing number of cells. Now we're gonna compute this guy. So we're gonna take cell xcom minus per initial position of this cell. So minus initial position of this cell that is stored in this particular dictionary. And you know what? I'm gonna copy this guy because that's why I did this first, like that. And we have to multiply it like this. Okay, then we're gonna add the same term for y. Y1 this plus, I don't know, I think I should be able to do that. And then let's do z 2 times this, z2, and like this. So at this point, we will increment sum of squares displacement by, you know, adding contributions from each cell. Mean squares displacement is equal to sum of squares over number of cells. And let's do some printouts here. So let's type mean. Let's type this C++ mean square displacement equals mean squares displacement. And what else do we want? Let's actually estimate diffusion coefficient. Again, it's not exactly diffusion coefficient. It will be quantity proportional to diffusion coefficient. Roughly, I'm not pretending that it's correct, but we can do something like mean squares displacement by current step. And okay, so I think this is reasonable. I'm going to get rid of this command, this commented code. Yeah, let's compile it and see if this even works. All right, so let's compile it and it got installed. Let's run it. And let's run it. So we get a bunch of estimates of mean squares displacement. You know, we should also get, I would suggest we add Monte Carlo step to this printout, because we don't know which Monte Carlo step we are at. So let's go back here. And C++ and MCS equals current step. Let's recompile. So see, this is the problem with it's not a problem, it's a feature of C++. Every time you're making any tiny change, you have to recompile everything. You have to close CompuCell3D, reopen it, and it's a little bit error prone. I mean, if you can, you know, can get used to it, but you know, okay. So that's what it is. So we can compute this mean squares displacement. Now, what I would suggest is that we write here in this code, let's write steppable. So this example comes already with a steppable that's ready to use. So all we have to do really is essentially write the same code in Python. So here's how I'm gonna do this. Let's bring this guy and let's copy some names so that we can use the same names. So initial positions. And now you can see why Python is much more fun to work with. So I'm going to create dictionary. And then here, I can use this guy, go over each cell, and then I mean sum this. And I can write it way faster. Oh, num cells. So I'm going to do this. That stands for displacement. And we're going to do, oh, you know what? We have to do one more thing here. First, we have to go over this. We have to implement start function. And self init conditions cell ID equals, I'm going to start as a list, XCOM, Y, Z, Z, Y. Now, this is the code that we wrote. And just for comparison, let's visit C++ counterpart. Where is this? This is how much code we had to write. I think Python is simpler, but you'll be the judge of that. Now, init com equals like this. So I get init com, and then I have dot xcom minus init com first element square plus 1 y 2 and z, and that's my mean square displacement. Then I have to sorry, that's my sum of squares, and mean square equals square displacement equals, what is this? For num cells, and then I can print MCS equals MCS, sorry, is it MCS? MCS, like that. Mean squares displacement equals, and my D is proportional to whatever, I think like that. Verb, yes. All right, so I'm actually turn off this guy, and let's run it with Python steppable. And I'm gonna actually do Python here, type Python. Why am I getting some highlight? Right. Format it nicely. Let's get rid of that code and let's run it. So you'll notice that it actually took me way shorter amount of time to write this code. Oh, expected. There it is. I forgot about colon here. Other than that, we should be ready to go. All right. Division by 0. Why is there division by 0? Because we don't want to be dividing when Monte Carlo step is greater. So MCS can be 0 here, right? So we have to be careful of that. So if MCS greater than 0, I'm just let's run this guy, and let's see. This is really interesting. I must have messed up something because those numbers are really weird. They're not anywhere close to what we would expect, right? You remember it was like, we had like numbers of the order of like 40. I suspect, so this is what I suspect, is that when start function is being called here, it's not being initialized properly. I mean, the cells are not being initialized properly. So let's see actually what is being stored in this dictionary. So I'm going to really print self positions, and I would expect that we should get a bunch of zeros. And I'm going to burn, because we don't want to run. Right. Let's go back to, it's really interesting. So it actually is computing things correctly. Why am I getting different numbers than I should be getting?
I think you should divide by the number of cells, shouldn't you? At some point. You are.
I am dividing by a number of cells. Well, let's see, actually.
I think you made a typo in the sum squared displacement for the Z components.
Which one?
Sum underscore SQ underscore display.
Yeah.
The last one, you take element 1, and I think it should be element 2 of the init underscore COM.
Oh, yeah, this guy. Yes. Thank you. Yeah, that would do the trick, definitely. Yes. Very good. Absolutely right. Let's see. But I'm pretty sure that this is the case. Let's run it for a while and then let's pause it. Oh, I'm sorry. I should have fixed one thing here. Let's get rid of this junk. No, that's more reasonable. That's the numbers we were getting. So you saw firsthand how long it takes to write relatively simple code in C++ and how long it takes to do it in Python. I mean, it was fairly simple example that involves just fetching center of mass, storing some numbers in the dictionary. It's nothing complex. You can easily extrapolate from here to more complex examples where you would need to use some fancier operations that are let's say relatively easy to code in Python, but I can guarantee that the same operations, same programming paradigms or idioms will be much harder to implement in C++. And then you would really see that your development speed of C++ code is roughly 10 times slower. But let's see what the benefits are. So this is what happened. Those files were open to edit. I modified them somewhere else. So to edit the text, those changes, and I can click yes for every one of them. Let me actually close those tabs. We don't need them anymore. But let's add some timing information. It will be very unscientific way of benchmarking, but this is good enough for our purposes. So I'm going to use time module. So import time. And at the beginning of the step function, because this is what we are really interested in, I want to benchmark how long it takes to compute this part. So I'm going to type T0 equals time.time. So time.time gives you a timestamp, right? And at the end, you're going to get final timestamp. T1 equals time.time, right? And then we're going to print maybe runtime. Runtime is equal T1 minus T0. That's all it takes. And this will be in seconds. So I can add seconds here. All right. So let's run it. Where is my code? Yeah, we can run it here. So the runtime is that. I know, let's pick this number. Okay, I'm gonna pick it and I'm going to store it in edit. So this is Python. let's do the same thing. I'm going to close this guy for now. And now we have to add timing information to C++. It's not as simple, I can tell you, it's not as simple as using time module in Python. I had to look it up. So I have a code on my other screen, which I'm going to copy. So first of all, there is this chrono module, chrono header file in, in C++, which we'll add. And then we have to add timestamp. So timestamp, so T1, just trying to see where we should put it. Let's put it at the beginning of the function. So this is the start. So essentially chrono, high resolution, clock, now. That's how you get timestamp. And end, we're going to put it here. And okay, so we have two timestamps. And now we have to write timing information. C++, timing, and then we'll have to do, what do we have to do? Oh my gosh, this is, so it will be like this. So the duration, so that's the interval, end minus start, and then duration dot count. Oops. Seconds. And I think we should be ready to compile it. Let's do it. Let's go to our compilation terminal. It's here. All right. Now I am going to go to Python code. Going to enable our steppable. I'm going to turn off this guy. Turn, so that we do it once, and let's run it. Where is our, there we go. I have to reload CompuSub before I do that. Okay, let's see. I don't know which one you want to choose. Let's choose this one. Maybe this one. Whatever. So this is how long it takes. Plus. Let's do some math. How do you
10
math?
times faster, basically.
10
times faster, basically.
10 times faster only. So Python. This over this guy. 30 times faster, give or take, you know. Yeah, so that's what you get by, you know, getting through the hoops of, you know, writing C++ code, you know, 30 times faster, you know. Everything depends, you know, on your use case, you know. But this is essentially, you know, 50 to, I mean, anywhere between 10 to 100 times faster. That's the speed ups you should expect when just converting to C++, you know. Another way to speed up your code is, you know, of course, you know, you can run certain things on GPUs if you can. You can use parallelization. You can, of course, use parallelization from Python. But the long story short is that if I'm comparing, let me go back to the code. If I'm comparing plain vanilla code, this is all Python operations, really. You would expect the equivalent code in C++ to be much faster. What does take time in Python? Well, just bare iteration over this guy, the cell list. It's slower, significantly slower than C++. Each time you're fetching, attribute of a cell like center of mass, you're essentially behind the scene. What happens is that this dot is a function call. It's a function. And if you look at the code for this function, it's not terribly complex function, but it's not, it's a function. It has a bunch of statements in C++. So it looks here like you're doing just simple fetch. In fact, you're not. So that contributes to some slowdowns. But ultimately, like when it comes to simulation development, Python is your best bet to start developing simulations. Just get this thing going, because you will quickly see that if you develop things in C++, it will be much more painful. Once you have your final version of the simulation and you want to speed it up, let's say you want to run, I don't know, 10,000 replicas of the simulation with different parameters, then you can consider rewriting your steppables in C++, as a C++ module. Obviously, you would first benchmark and make sure that indeed rewriting things in C++ makes sense. In this particular case, I don't think it, in this particular example, it doesn't make any sense. You should be perfectly fine running this code as written in Python, especially that you probably would not call this code every Monte Carlo step. You would call it every 100 Monte Carlo steps or something like that. So in this particular case, the overall speed up is minimal. But there are situations where really Python code can be detrimental to your performance, and in that case, writing C++ module is a good option. I hope I convinced you that using this little generate new module is actually very handy, because with one click you get 10 files. You get module Python C++ compusal module that actually is functional. It runs. It doesn't do anything interesting, but it's a good placeholder, good starting point. So instead of you spending time figuring out how to wire this code, you click this button and everything is pre-wired for you. All you have to do is just supply some logic. And once you do that, you can really build cool simulations. So if you go down that route, if you start using C++, let's say to write your paper or whatever for your research, and then at some point you decide, look, I'm done with this type of research, I'd like to share my code, just go ahead, contact us. You can do pull request. You can essentially go to where is this? I had it here on my screen. You can go to Compusal, and you can fork our repository and then create pull request, or just simply send us the code if you want it like that, and we can include this code in Compusal. We had several contributed codes from other people. They use Compusal for the research, but then they wanted to share their modules because they found that they were useful, and that's how it goes. So that's all I have for today. This is, I try to make this session very simple. I didn't go into plugin development, but because this is a bit more advanced topic, how to develop plugin requires you to know a little bit more about how Compusal functions. Internally, I hope, I'm sure it was covered. James or TJ have covered it at the beginning, but it's still, more complex topic than I wanted to cover today. So, okay, so I think that's all I had for today. I'm wondering, if there are any questions, if you have suggestions, or if you want to discuss things, just let's open the floor.
I have interesting steppables I would like to implement in CompuCell that is actually implemented in other versions of POTS, which is acquire which are the new cell pixels and which are the lost cell pixels. So, for example, from step 1 to step 2, the cell acquired 2 new pixels and loses 1 pixel, let's say.
Yes.
Okay. So in the newly acquired pixels, you set a field to 1.
Yeah.
Okay. And then as these pixels become older, you reduce the field.
Yeah.
So you have to either track all cell pixels and assign a time, a age, let's say, for each pixel, which in Python would be extremely slow because you have to each pixel has one attribute, and you have to scan all cell pixels each Monte Carlo step. So well, that's my idea for steppables, right? It would be a steppables in this case, not a plugin, I think. And I have to access, for example, cell field, set a cell field, decrease the field, make it decay. The built-in decay already works, I think. We don't need an age, I think. Yeah, an age wouldn't be necessary. And also what this field do is it promotes chemotaxis. So the newly acquired pixels are an anchor point for chemotaxis, so the cell would continue protruding in that direction.
Yes.
Can you visualize it?
Yeah, no, I know exactly what you're talking about. Yeah. So,
okay.
So yeah, no, that makes sense. Yes. So 2 comments. You can definitely write in C++. It will be fast, but there's also a fast way to do it in Python first, just to test it works. So the idea is to use pixel tracker boundary. Sorry, cell pixel tracker plugin. It's called. I forgot what it's called, really. So for each cell, you store a set of pixels associated with a cell at time t0. Then at time t1, you get new set of pixels, right? And then you subtract the 2 sets, right? And you know which pixels were created, which were not, by doing like set algebra.
Yes.
And that typically will leave you with 3 pixels that are lost and 2 pixels that were created. Iterating over those 2 pixels or 3 pixels in Python is actually fast. So you could start it that way, or you can, as you said, you can use C++ module. It's not a big deal to write this steppable. We're not going to write it right now, but I can tell you that if you rewatch this video, or if you can talk offline, we can fairly easily get you started and get you going with your problem in C++. It's not going to be much more difficult than what you saw today. Just a little bit more, C++ code, but nothing terribly difficult. So yeah, I mean, that's a good idea for steppable. And you
So
can
what
go.
about I implement it in Python, and then I rewatch the video, start implementing in C++. If I face any problems translating one to the other, I send you an email.
No, exactly. And you can send it to me, and I'm pretty sure that this should work like the way I described. There might be some minor issues in terms of like how to handle sets of points, but we can figure it out. I mean, really, in any case, probably even in C++, I would still use pixel tracker because that could be quite useful. And I would also attach attribute to a cell that keeps set of pixels from the previous step, so that you can compare the pixels at time t1 and t2. for a given cells, because typically pixel tracker will only give you instantaneous number of pixels. So you need to have a way to store those.
Yes.
Yeah. So here we actually used, like, if we go to this code, we used, what did we use? The dictionary, This is the simplest way. If I was writing CompuCell code, really production code, I would not use this approach. This approach works because cells are not created or destroyed in CompuCell, you know what, in cell sorting, this cell sorting simulation. But in general, if I were to write code that uses cell properties from previous times, I would use custom, like I would attach attributes to a cell. It's easy to attach attributes to a cell or dictionary to a cell in Python. It's not too difficult to attach them in C++. So this is just my comment.
Okay, I'll try.
Any other questions? Hope it wasn't too much. Could be too much. I mean, it's a little bit more advanced presentation compared to probably what you have seen in earlier workshop sessions. But yeah, I'm glad that you attended, and hopefully I didn't scare you away from C++. That wasn't my intention.
I noticed you didn't declare this cell initial positions dictionary outside of 4. So from
Here.
my experience
It's declared here in
okay.
Yep.
Okay.
Yeah.
Okay. So this STD double column would be the analogous to self dot something?
No. So there are namespaces in C++. So for example, this class, cell diffusion steppable, sits inside CompuCell 3D namespace. So this unordered map class sits in STD. This is STD. It's essentially namespace for standard template library, which is essentially the basic namespace for C++ code. It essentially contains all the standard utilities that C++ has, like list, vectors. If you want to use vector, you would type std vector. So this is the issue with C++. In order to actually use it proficiently, what I would suggest is, there are a few things you need to learn about C++. You need to learn, okay, how the parameters are passed. There are 3 ways to pass parameters: by pointer, like here, by value, like here, and by reference. Okay, you have to know the differences between the two. Number 2, you have to learn a little bit about inheritance of classes. Number 3, it would be ideal if you have to know pointers, obviously, difference between pointers, references, and then standard template library. Standard template library, essentially, you don't have to really be an expert in templates, but understanding how you create, a vector of integers, right? So it's a vector, and you specify what type of elements will be stored, integer, and you call it my array, okay? And then you have to learn how to allocate the vector. The nice thing about using standard template components like vector, you don't have to deallocate anything, right? But in C++, you can create a pointer and forget to deallocate it, and you can create memory leaks. It's not the end of the world. Your computer will crash, but all right. So James is.
So just trying to ask a few questions here to the group. That's great. That was very helpful. I don't know if there are people who would like to see, maybe tomorrow, I don't know, how to write plugins, because that's, as you say, more advanced topic, but also quite interesting. I know personally, I'd love to learn how to extend Twit and how to write wizard pages, and also how to write XML extensions, because those are all things I'm interested in. I think some people would like to just be shown how to edit the manuals, because there's several people who volunteered to edit the manuals and help us out. But Cesar had a question, just a Python question, which is if you want to export or import PIFs, how do you do that?
That's a good question.
Do we have a PIF exporter, or do you have to do it by hand?
So if you go to CC3D, and this is, let's say it's running. This is the running simulation. There is tools and generate PIF from current snapshot. That's one way to do it.
Can you do it from inside the Python, or do you have to do it from
the... I definitely you can. I just don't know it off the top of my head, but if I were to look for it, where would I look for it? That's a great question. Let me try and see if I can find it somewhere here. Export PIF. You know what? Let's do PIF. Let's do PY. Oh, wait, that's interesting function. What I think, hold on, this looks good. Let's see how the arguments look for this. Okay, this should work. So what you would type, let's go here to, where is PyCharm? I don't want this guy. This guy. Okay, so you'd probably do something like this from CC3D. Like, how do you import player? Player 5 player, Python player, Python. I think I'm not sure about the exact syntax, but then you could say, what is this? Oh, I'm sorry. Had it on a different screen. Come on. No, I don't know what happened with my other window. But there is a way to call it. I mean, I don't know. I don't know off the top of my head. It could be somewhere in. I'll have to look it up. But there is a way. So I can figure it out and send it to you. I don't want to spend time right now. So.
Okay, but you can do it from player, so that's a start.
Okay, and somebody asked me for that, and I yes, you definitely can do it from player. I have too many windows open. Let's see.
I think Lampros also wanted to show you the problems he's having with player and fields locking up.
Yes.
And I have a bug to report, which is that the simple message window crashes.
Oh, okay.
When you write to it, the demo I wrote crashes. And I can share that with you.
Yeah.
It's very simple, but it's so there are a couple. It may not crash on you're on a Mac, so it may not crash on a Mac.
Yeah, I mean,
so if Lampros, you want, I mean, there may be other questions too, though. So
I can stop sharing.
Lampros, why don't you screen share and show Maciek what's going on? And I'll queue up my little problem when we can. I don't, it's unfair to do this to you, Maciek, but it's a rare privilege to have access to the developer. And I know people are very excited by the opportunity. I know there were people who wanted to learn how to write plugins. So that for today, that's a lot. You've already given us a lot of your time, but I know okay, but Lampros, go ahead.
Yeah, screen share. Okay, give me a minute.
Maybe permissions to start sharing the screen.
You should have it. If you don't, I can give it to you.
Yeah, it lets me screen share. So can you see my screen?
Yep.
Yeah, so we had some problems earlier. So for example, I'm trying to open a new graphics window and it doesn't open. When I run the simulation, it usually opens it, but not all the time. Plus, sometimes when we're trying to change to something else here, it doesn't change, doesn't happen all the time, not for all the graph windows. So right now it does, but when we stop the simulations and run it again, we lose some of the windows and have to readjust them. That's what I remember from earlier.
Can you send me the simulation? It's a demo, right? So there's nothing.
No, this is our simulation. We just called it a demo.
Okay.
Yeah. I think that was it.
The thing that I'm having is that the tracking fields don't always update. They'll lock. You have to click on you have to hover over and click on the field to get it to update.
That's interesting.
I remember we had in old versions of CompuCell, but I haven't seen for a while. And also, again, as you point out, the tile sometimes there you see the aspect ratio gets messed up.
Sometimes we lose the aspect ratio. One time it was almost.
That's interesting.
Yeah, but when we click on it, it readjusts.
Okay. I'm just trying to think. Okay. Yeah.
So what I noticed is that some of these things, I don't know if it was it had anything to do with it, but I noticed them more when I used more cores through the XML file.
Oh, yeah. Okay.
So up to 6, it would be mostly fine, but when I went to 8, I had some problems with drawing of the windows.
How many cores do you have on your machine?
8 cores, 16 threads.
Okay. That's interesting. I'm just wondering if this indeed has something to do with number of cores. But if you run single,
this problem even if there's only one core. So I don't believe it's.
Do you have like example of simulation where those tracking feeds don't update, they lock up?
It's intermittent. That's the problem.
Okay.
Sometimes you run it, it's okay. Sometimes they'll lock. sometimes you close the offending window, open a new window, it's okay. Sometimes it isn't.
Okay.
I'm wondering if it's I remember there was a period when tracking fields failed when there was a negative number in the value somewhere.
Oh, yeah.
But I don't think, but these tracking fields are showing occasional negatives and they still work. So it's not that, or at least it doesn't seem to be that.
So even right now, it doesn't seem to have a problem when I have 4 cores in, but I think that it happens more often when I pick
Mhm,
8.
Yeah. No, I believe.
No, now it didn't happen. I'm not sure.
That
Yeah.
makes it a little difficult with those. We have to sit and play with it together because it's not consistent.
Yeah, I'm wondering why. Like, I'm wondering whether, if the same, like for the same simulation, if we could reproduce the same error behavior on Linux or on Mac. On Mac it will be different because Mac doesn't use this type of layout where Mac has different layout of Windows, so you don't have this multi-document interface where you, like on Windows, where you can do tile. You have just like the interface and the windows are separate. So which, by the way, you can enable also on Windows as well. So Windows, you can change the layout. And yeah, I have to check. I know that this multi-document interface, that the one that allows you to tile or cascade windows, it's been popular at some point, but it's been phased out a long time ago. So yeah, I mean, definitely worth looking into.
Also, something that kept happening, the window which was graphics 0, the first window that appears.
Yeah.
That one, for me at least, presented the most problems in changing what I wanted to see in that window.
Okay.
So although I clicked on something else, it didn't change.
Oh.
But graphics 1, 2, 3, etc. Mostly changed.
Okay.
But the graphics 0 for some reason refused to change. Yeah.
Oh, that's interesting. I think from what I remember, the graphics 0 is, I have to look into the code, but maybe a separate, it might be created in slightly different way than all other windows. I forgot the reason why, it's been a while since we wrote that code, but it might be something worth looking into. Yeah. No,
that's all from me. Thank you.
Yeah, thanks for going over about those.
Okay, I guess I'll show my bug. There are a couple of there could be feature requests too. You're allowed to ask for features too when you've got some of the attention. But let me just show my bug for a second. Oops. Let's see, it's not what I need to be screen sharing. Here. This is just a very simple simulation.
Wait, are you sharing your screen?
Am I not?
No, you're not. I think I cannot see your screen.
Sorry.
Oh.
Okay.
Yep.
So let's go to player. Let's see, player.
Yep.
There.
Oh, sure. Scroll down because I bet what happens is that I'm clearing out scroll down the code. No, this is fine. This is keep going. And then there is, and yes, keep going, where the place where you write to the message window. Print. See, but that's fine. Look at the line above. If not,
Yes.
So every 100 Monte Carlo steps, the window will be cleared.
Yes.
But but then it doesn't write back, right? That's the issue.
No, it crashes at a random time.
Oh, really? So it crashed?
Yes, the player died.
Oh, let's see how.
Player died.
Let's
No,
show. Do you have like the output from the? And this is, which one is it? This is, send this to me.
I did, but here,
Oh, good.
let's see around it. Let's see how it's 290. It died at 290 this time.
Oh, okay. I'm
Let me
just
put it again. It's going to die at a different time.
at a different time. And if you didn't have window, this, if you didn't
It
have,
wouldn't crash.
it wouldn't crash.
Some kind of stack. There's something strange about these windows because there's also a huge lag in writing to the window. This time it got crashed at 390.
Oh, yeah.
So it's probably crashing on the clear.
I think it's not crashing at the 390, it's crashing at the 400, but
Right,
the 400 doesn't show.
Yeah.
Let's get rid of the clear and do a pass there and see. But I think it still crashes because actually I put the clear in because it was crashing because I thought it was an overflow in the buffer on the size of on the amount of data in the window. Let's see if that'll crash. Now, something that is funny is that the writing to the window takes, well, this time it's working. Sometimes takes a long time. So if you hit pause, it will keep scrolling for a long time afterwards.
Oh.
Of course, this is like taking your car into the auto mechanic. When you're in front of the mechanic, it doesn't do whatever annoying thing it normally does. So this time it's not crashing. So this time it looks like it's associated with the wind clear. But I know running this without the clear, it was still crashing occasionally.
Yeah, okay.
I put the clear in because it was crashing.
That's interesting. Yeah, okay. That makes sense. I kind of think I know what's going on. Probably while the window is being still refreshed, there is this request to clear. Yeah, I have to look it up. Yeah,
It's locked. There's a lock, and so when it's trying to clear when it's locked, there's a problem. Is that what's going on?
Yeah, maybe. I don't remember really how
Yeah, this time when I pause it, it pauses immediately. But before there was a buffer issue where I'd hit pause and it would keep scrolling for
okay.
a long time.
No, that's fine. So yeah, okay. That's definitely something. And it's window. Okay. I can definitely look at this.
It's minor, but it was just something it was a demo I was teaching and I noticed the problem. So
that's fine. No, that's good.
but at the moment it seems to be associated with the clear. The layout issues are reasonably and I know there's this problem that with the pop-up the pull down windows here it's pulling up correctly, but those pull down menus when you say you want to change say cell field in the graphics,
I know.
Just pull up random places.
I know, and this happens. Well, actually, maybe it happens. I don't know. I have to look into this. Why this happens at all? Because it shouldn't. And I suspect it's something with. I mean, it must be something with Qt, because I'm not using anything. I'm just using standard Qt components. So.
The plot window, the scientific plots also occasionally will have well, it's as you know the axes don't always plot right. The player will get confused about how big the screen is, and then the axes on the plots will get messed up.
Yeah.
So that one I know we've talked about before.
Reading some suggestions.
It's pulling the size of the window, say from if I have two screens, it'll pull the size from the wrong screen and then lay it. Most of the stuff lays out right, but the scientific plot axes are messed up.
Yeah. Yeah.
Remember which example we had that did that. That's
I remember that, but well, yeah. Wasn't it logarithmic plot with some crazy numbers of which you cannot
oh,
take?
just it does it for it's the axes that are the problem. It's actually
Oh,
see if
Hmm.
it'll yeah here. Let me show you.
yeah. But you have to share the screen. And make it larger. Oh. Yeah. Why is this? So this is just a single plot and it's completely messed up axis, right?
Mhm.
Send this to me. It happens always, right? Like that.
Well, so if I pull this back onto my other it's because it doesn't know to change the let me reshare.
Oh,
The
okay.
issue is that it's pulled the resolution from the screen that it thinks
Yes. Yes.
the display is on.
I know. I
Uh,
know.
but then even getting rid of the SQLite file doesn't help. It doesn't seem to be able to handle a second screen. Doesn't know that resolution is second. Now, obviously, a lot of things do because they plot properly, but that doesn't.
I wonder if this is issue that it's our issue or
Qt.
it's PyQt charts thing. I don't know what's the name of the library. I think it's PyQt. Let me Google it up quickly. Yeah, and you know, if this is PyQt chart, no. What is the name of the library that we're using? No, that's not that.
Well, I mean, these are some examples. I was doing this not so much because I was hoping you saw these here, but because I wanted to encourage other people to be brave and to bring things up.
Yes.
Although they are things that need to get fixed. Any other questions for Maciek while we're here? Could be anything. How do I update the manuals? Gee, I need a plugin. How do
Yeah,
you?
that one is good. How to update the manual, Maciek, since me and Fateme are probably going to do this starting, I don't know, today, tomorrow, next week.
Yep.
So we want to go ahead.
Yeah, so let's go over this. So how to update manual? First of all, I don't know where our manuals are stored. Let me check. This is the place, or if we have them somewhere else. I think this is the landing page where you should go. And repositories. Okay, let's say you want to, which manual would you like to update? Probably maybe Python scripting manual. So you would go to, let's repeat the steps. So you go to CC3D, then repositories, because only a few repositories are being shown here, repositories. And then you go to Python scripting manual. All right, so this is where the manual sits. And then you would clone this code and open it. Let me actually show you what I would do. So I am going to clone this code. I'm going to copy it. And can you see my screen, by the way? Am I sharing?
Yes.
I am sharing. Okay, good. So once again, I click here, copy this line. Then I go to make dir manuals, cd manuals, then git clone that I copied. All right, so I have it here. Now, let's say I'm going to open, and I should go here. I'm going to open in PyCharm. I think PyCharm is the tool I would use for most of Python programming, to be honest. Open, and then I should have manuals. That's the new folder I created, and I will open this guy. New window. Okay. So first thing you would need to do, you would need to create new branch. So this is all under version control. So I'm going to create new branch called my fixes. All right. Now, how to create branch? Just go slowly. You go to Git repository, branches, and then we were here, and you would create new branch from master, and then name the branch. But I already called this my fixes, feature my fixes. Okay. And now, I don't know, let's so we are using RST format. So RST format is being described best. Let me check actually RST. There are two markup formats that are popular: Markdown and restructured text, which is RST. So I don't know which one is good, but it explains how you do various formatting. You have to look through that, but there is plenty of material about restructured text. Probably this one is good. The third link in Google. But okay, let's go back here, and let's say I want to change our Python API. So if you put those, if I want to do warning, I'm going to type warning. It will automatically, PyCharm will automatically help me with that. And then I'm going to type, hello, this is how you edit manual overview. You can, of course, do, so, underline is as a title, if you do, so there are headings, section headings, and you use different formatting, and you have to see the manual. But okay, but let's say I added this warning here. Okay, this is my preview. Then I need to commit this file. This is, I added, push it to the repository. So normally you would have to fork this the repository. We can go over that offline, but you're going to push it. And then once you're done with your, so let's see, when I go here, I should see two branches, actually more branches. Let's see. Feature, my fixes, right? And you can see that I pushed change less than a minute ago. So I'm going to go here to this my fixes branch, and I'm going to compare and create pull request. So this is my edit, and you want, so this branch, my fixes, contains your edits, and you want to incorporate your changes into master. So you would, I don't know, pick reviewer here. TJ is reviewer. You can request other reviewers, like, I don't know, CC3D. And you could create pull request. Add it. And you would create pull request. And this is how you would contribute the code typically. Alternatively, you can, if you don't like this process, I think this is actually a pretty streamlined process because, when I see something like that, pull request, I can go and see what has changed. And here it is. Here's the change. And I can incorporate it. And once I incorporate it to the source code, once we incorporate this change to the source code, we should be able to see this, for the sake of demonstration. I'm gonna review changes, looks okay. I'm gonna approve it. Well, except I cannot do review changes. I'm not sure if I can approve it, by the way. So I cannot approve my own pull request. But in general, that's how you would do this. Once this change is merged, the changes will be automatically reflected on the web page. So that's how you edit manuals. And you would do the same for any other manual. Let me actually log in as CC3D, and I can approve my change, and so that you can see that this is being updated. So where is this guy? I'm gonna log out, sign out. Right, so this is me, and then I'm going to go here. So I can actually show you that one here, and I got pull request, Python scripting manual, pull request. Okay, and it looks like I can files change, review changes. That's what I would do. If you submit changes, submit review, and then I can merge pull request, or merged, delete branch. Then we should see this guy warning in CC3D Python API. So let's give it a little bit of time. So now there is a backend that essentially generates HTML pages. CC3D.org, manuals. Use Python scripting manual. Maybe it didn't build correctly. I don't know, latest. This word arbitrary. Jupyter Notebook. Search for this word. Here we should see warning. There it is. So it takes a little bit of time for this change to propagate. But you can see that you can really do it like this. And, it might take a little bit of, getting used to things. Yeah. If you have your user ID, GitHub user ID, let me know and I can add you to, or I can show you how to essentially fork the repository and then create pull request. You can do one-on-one training, if that makes sense. I think it would be more useful to do it like that than going over this quick presentation here. Any other questions?
I think one last question is creating energy plugins.
Yeah, but this is complex topic, so I'd rather not discuss it here right now because it's
Is it possible to for us to organize some kind of developer workshop?
Yes, it is. Absolutely. So, you know, for that to get started, let's see. Computer reference manual. This is developer's manual. So I think we are going over that steppable. No, I didn't cover it, but yeah, so that definitely worth. I can add some material here. How to develop plugins. Because right now I cover only steppables.
Mm-hmm.
Yeah. Yeah, definitely. I mean, the process will be the same as for steppable, but it's more involved because it involves actually understanding of CompuCell internal logic, how it does the pixel copies and stuff like that. But yeah, it's possible, definitely.
Yes, I actually read the documents. Yeah. Maybe I should try.
Yeah.
Yep, that's fine. I think that's great. We should thank you, Maciek. Any other questions from the audience?